Okay, we're in example, the examples for section 8 of the notes. Again, I know it's for some students a difficult section. We're mixing ideas here, certainly ideas from the past. And what's difficult here is that the level of work is more difficult than it is for polynomials, right? We'll go through these examples, again, with the hope that we reinforce what was discussed in the lectures. We're trying to reinforce that information. Again, that requires effort on your end, though. It isn't like a passive thing that we pour things onto you and you'll get this. You got to work at it. And it takes time to work through it. So just to give you the structure again, we'll go through these examples over here. I do provide graphs for you. Again, I want to point out when you're looking at this over here, if you click on these red links, they'll bring you directly to the graph. But it also says it's figure 52 on page 152. So let me click on that and just show you, whoops, right over here. That's figure 52, and it's on page 152. All right. So this is a nice graph over here. And when I say a nice graph, a machine did it. You'll notice that the graphs I'm going to do, if I do them by hand, they tend to be quite crude. All right. You want to learn how to use technology, by the way. So throughout the notes, these examples over here, you're certainly going to see work in the blue area like we always do, but I'm going to do work at the whiteboard. So we're going to switch over to the whiteboard. Our intent here is to go through all these examples, again, with the hope that you're going to pay attention and make some attempt to understand what's being presented to you. After you do that, though, there's going to be a set of questions that you need to try on your own, right? You really try. And that's the part where we want everyone to move forward on, is trying, and trying at something. All right. So let me just point out what I mean by that. I know it seems long. Yeah, there's graphs make these much longer, but there's supplemental problem sets. And the supplemental problem set, what are you doing? You're doing the problems, right? You do that on your own now. I'll publish those videos later in the week, though, for those students that don't want to watch those. But again, if you're following along and you're studying, this should go smoothly. It really should. All right. It's something that is important, though, that you want to move forward. Okay. Let me switch to whiteboard. And we'll do one problem at a time. Again, for the students finding this hard to follow, within the notes, you have embedded videos, or you can watch these videos towards the end of the week if you like. I'll put them up. All right, let me just get my whiteboard going. Let me see if I'm going to plug it in. Just give me a second here. Gotta get my cable out. Give me a minute. Okay. Let's take a look here. All right, so we're at the whiteboard, and what I want to claim to you is that we're going to do one problem at a time. And certainly, what's the structure of the notes? I kind of move things around a little bit, but the bottom line, you're given a question and you're given the partial graph of it. All right, so let me read that to you. You're given f of x equals y equals yada, yada, yada. What do they give me? They give me both the function itself and they give me the factored form of it. And I'll go through that with you. All right, so let's put that down first off. So what are you given? Let's write this down. You're given a function f of x. They say f of x is y. What does that mean? Y is a function of x. What's the function going to be? X squared minus 3x minus 4 over 2x squared plus 4x. Well, I would say the first thing you would do, although it's been done for you, is factor it. All right. So if I did that, what would you get? The bottom's really easy to factor. 2 would come out and an x would come out. And what are you left off with? X plus 2. That was simple. The top is a quadratic, and I'm hopeful it factors. What do you get over there? X times x is x squared. I would say probably 4 and 1 because I'm seeing 3 in the middle. Again, I would never say this is true until I try it. And I'd say minus 4 plus 1. And does that work? You do get x squared. Minus 4 plus 1 is minus 3x, and you do get minus 4. All right. So I'm going to say the way they wrote it's good. I like that. All right. Now they say, well, what are you going to do now is answer questions one at a time. And certainly I want to answer one question at a time. And we'll look at the picture later. So letter A says, what is or are the y-intercepts? I don't know. How do you do that? You set x equal to 0. If you did that, it's really simple to do that. It's just simply f of 0. What's f of 0? Well, you plug it in. And someone says, where do you plug it in? On the top and on the bottom. Unfortunately, what happens though, if you plug it in top, you get 0. That's not a problem. I'm sorry, you get -4. That's not a problem. On bottom, when you plug in 0, what do you get? You get 0. So there is none. This is undefined. So there's no y-intercept. I'll put that in a box. All right, let me just go to the answer and make sure you understand what we're talking about over here. It says, just set x to be equal to 0. I'm reading this over here, and you'll see the dreaded division by 0. Yeah, I saw it. So there's none. All right, A is done. Now, someone's going to say, what does that mean? Well, all it means is there's no y-intercept. Let's go to B now. All right, and what's B? It says what are the asymptotes in the problem? And except, what asymptotes? The vertical asymptotes. So I want to point out that's where students get really confused. All right. So I'm going to say the places where vertical asymptotes could occur is where we're getting those divisions by 0. All right. So what I want to do is, I realize I got limits written down over there, but I realize some students may not be ready for that. Now, of course, when you get the calculus, you can get ready for that. All right, let me get my eraser because I got a trace mark over here. So what I'm going to talk about is just simply sign analysis in the problem. All right, I'm going to talk about sign analysis first. We'll go over what my work is indicating there later, okay? So what I want to do is sign analysis. And sign analysis on what? Well, on the function. So I'm going to write a number line down. And this really goes back to the very beginning of the semester. And I'm analyzing the sign of the function. And where would the function become 0? Well, at -1, I'm going to write this down for you. That's where the top becomes 0, by the way. And at 4. Okay. Now, where does the bottom become 0? That's where it's going to change signs, by the way. At 0. And at -2. Okay. And what are we going to be doing? We're analyzing the function. We're analyzing the function for sign now. All right. And this is important. So what do you get over here? Well, if you look at it, and again, we'll get to the limits later. I just want to take some test points here. And what would be a good test point over here? I would say 5. What would be a good test point over here? Well, looking at it, I would say, I don't know, maybe 1. Right? I'm not going too fast here. I would say probably -0.5 here. I would say probably -3/2 over here. I would say probably -3 over here. Let's do one at a time. When I do this, I'm taking the 5, I'm plugging it into this thing over here. Positive, 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 positive. Everything is positive. Let me write that down for you. All right. Again, all I'm doing is taking easy values. I want to go to 1. Up here, positive. This would become negative. So top is negative, the bottom is positive. What does that tell me? It's negative. All right. I'm going to go to -3 because I find it easy. What do you get over there? Negative, negative. That's a positive now. Negative, negative. That's a positive. So what do you get overall? Positives. Now, someone's going to say, if I make a mistake, will I know that? We'll know that by looking at the picture. But right now, let's just see if we can continue through. And I want to get to that limit stuff first. I mean, after I do this, I want to get to limits. Let's try -1/2. What do? Plug it in. Positive, negative. So the top is negative, negative, positive. The bottom is negative. What does that mean? I get a positive overall. Again, if you're struggling with this, you're really struggling with the first class, which is the first class we did this semester, was on sign analysis. It's a really important concept. Now, if you try -3/2, it's tough. I know that. This would be negative. This would be negative. So the top is positive. This is negative, and that's positive. So what do you get overall? A negative number. So now what I'm going to do, I'm going to use this sign analysis to help me with the limits. It's going to help me with the limits. And let's write this down. And again, we'll look at our key later. Now, what I want to do is I just want to look at the bottom where there's trouble on the bottom. And the trouble on the bottom is only at two places, at 0 and at -2. I'll write that down for you. So I'm looking at f of x equals, and what does it equal? Well, it equals x squared minus 3x minus 4 over 2x squared plus 4x. And there's two places I'm very worried about. The two places I'm worried about is this over here. I'm worried about when we get close to 0, that's limit, from the right side of f of x. And I'm worried about the limit as x goes to 0 from the left side f of x. We'll look at the answer key later. And I am worried I'm sorry, I don't want to do 0 again. That'd be crazy. What's the other number we're about? -2. From the right, and the limit as x goes to -2 from the left. Now, before I do anything, I want to just simply discuss the signs of this and the meanings of these things over here. So let's just take a look at 2. I'm sorry, -2. This is -2. Let's do 0 first. This is 0. From the left side of it, this is the left of 0. What would it be? It would have to be positive. Again, this is 0. This is the left side. It must be positive. All right, let's go back. This is 0. This is the right side of 0. Right side. What is it going to be? Negative. All right, we'll talk about what the meaning of this is later. And then we'll look at our key to make sure we got this okay. All right, I want to go to -2 from the right side. This is -2. This is the right side. What is it? It's negative. Let's keep going. -2 from the left side. This is -2. This is the left. What does it say? It's positive. Okay. The key here is you have to worry about what's happening here. And what's happening when you plug these numbers in is the bottom is becoming 0. You should realize what that means is we're getting close to a very tiny number. So what are we getting? We're getting a blow-up problem. What's a blow-up problem? The bottom is being divided by an incredibly small number, super close to 0. In the limit, we say it is 0. And it's going into some finite number on top, and it's blowing up without bound. So all these guys over here are going to be infinities. I want to go to the key, and I want to see if we did a good job in that. And so I'm looking at it one at a time. Let's look at this over here. All right. So I'm going to just do this one first. This is the limit as x approaches 0 from the left. It says it's infinity. Did I say that? Yes. Let's go to the next one. As I approach 0 from the right, it says it goes to -infinity over here. I said that too. Right, we'll go to the picture later, by the way. Then let's look at this. It says, as you approach -2 from the left, it says -infinity. Let me show you that. Whoops, I think I made a mistake. Oh, I'm sorry, -2 from the right is minus, I'm sorry, I looked at the wrong one. And this one says -2 from the left. It says +infinity. All right, so I'm going to say we did A, and we did, oh, wait a second, I just did A. I wasn't expecting to do that. Let me go back. I went out of order. I'm sorry. Let me go to B. But anyway, that's done. E is done. So this was A. All right. All right, let's go to B. B says what? What are the x-intercepts? Well, let me write this down again for you. And I'm looking at it. This is B now. What are the x-intercepts? It's when the function is equal to 0. Well, what's the function? The function f of x, I'm going to put the factored form down, is x plus 1 times x minus 4 over 2x times x plus 2. I push this up. We'll look at the key later. So I'm going to say, when does that function equal 0? Only when the top becomes 0. When does the top become 0? At minus 1 and at 4. I'm going to write that down now. So at minus 1, the function becomes 0. And at 4, the function becomes 0. Again, I'll look at the graph later, but right now we're just looking at the k. All right, let's take a look at it and see if they wrote those answers down. Well, I'm seeing it, minus 1, 0, and I'm seeing 4, 0. Again, we'll look at the graph later to emphasize that this information really can help us graph it out. What's the domain of f? Fairly simple. It's going to be all real numbers except those places where this function is undefined. Well, if you look at the function again, and again, this is the function, there's only 2 places where it's undefined, and that's where the bottom becomes 0. When does the bottom become 0? At 0 and at minus 2. So I'm going to write that down for you. Sorry about that. Whoops, I didn't mean to do that. And this is going to be C, and we'll look at the key later. The domain is all real numbers, except at 0, and except at minus 2, because that's where you have division by 0. Let's write that down as intervals. Minus infinity to 0, union 0. I'm sorry, I made a mistake. I'm not thinking. And the reason I'm not thinking I had the minus 2, probably it should be for the 0. But anyway, minus 2, union minus 2 to 0, union 0 to infinity. By the way, I don't mind the way that's written, but we're really steering towards intervals. So let's take a look, see how we did. Let's see if we got C. What is C? Let's take a look at it. All the real numbers except 0 and minus 2. I'm clearly seeing that. Okay. Let's do D. And what does D say? What's a horizontal asymptotes? All right. So what I want to do is I want to discuss this with you. And I'm going to just simply talk about it. All right. And the way we're going to do this is we're going to do it with limits. I know it's new, and I know this is difficult. All right. We're on D now. Whoops. And I'll go through what we did in the lecture portion. The limit as x goes towards infinity of f of x. We'd like to know what that is. Right? The way we do that, the way we're recommending you do it, is you divide the top and the bottom of this rational function by the highest degree variable. What's the highest degree variable? X squared. What would you get? 1 minus 3 over x minus 4 over x squared. This is our recommendation. Now, if you divide the top by x squared, you divide the bottom by x squared. What would you get? 2 plus 4 over x. I want to remind you what f of x is. F of x is x squared minus 3x minus 4, and the bottom is 2x squared plus 4x. Again, here's the deal. I want to emphasize this again to you. The highest degree variable in the problem is x squared. We are dividing every term, top and bottom, by x squared. We get this over here. Now, what's interesting about this? If you were to do that and you were divided by a very, very, very large number, what would happen to these terms over here? Well, 3 divided by a very large number is very close to 0. 4 divided by a very large number squared is really close to 0. So what are you left with on top? 1 minus 0 minus 0, which we know to be 1. What do you get on bottom? 2 plus 4 divided by a very large number, which is 0. You get 2 on the bottom. So what do I get overall? I get 1 on top, 2 on bottom. Now, if you do the same thing going towards minus infinity, by the way, don't always believe they're going to be the same. I just want to go through it again. And again, we've already divided by highest degree variable. I'll put this over here again. And yeah, I know these problems take time to get through. I do want to promise you, as you go through this, it's going to go quicker over time. And this is also going to be 1/2. And again, let me repeat why that is. You're dividing, although by a negative number, it's still an extremely large number. And these are going to go to 0 very quickly. And so will that. So you get 1/2. So what does this give me? It gives me a line, and it's horizontal. And what is a horizontal line going to be? The equation that's going to be y equals 1/2. And that's the same in both directions. All right, let's look at the key. They got the work down, and this is the work over here, and they have the answer down over here. So let's see if we've answered all the questions. And the last question is, what's the range? And this is the part where, I'll be honest with you, it can be really tough. There's no doubt about it. Range can be a killer, especially when you don't have other tools available to you except pre-calculus. But what I'd like to do is, I'd like to talk about the graph. Now, by the way, I'm hoping this information is readily available to you. But if we're looking at the graph, what I want to do is I want to put down what I found. All right, so I'm going to look at this graph over here, and I want to tell you what I found in the graph. And I'm going to write this down for you. I found there is a horizontal asymptote, and the equation of the horizontal asymptote is y equals 1/2. I hope you can recall that. I found there were two vertical asymptotes. One was going to be x equals 0, and the other one was x equals -2. All right. I also found two x-intercepts. And what were they? One of the x-intercepts was this one here. That was -1, 0. The other x-intercept I found is 4, 0. All right. Remember, we did sign analysis. And you may not remember that, but it should be in front of your notes over here. What did I say? Well, I said between -1 and 0, the function was positive, and it was asymptotic. I hope you remember that. I'll put this over here. When you went below -1 towards -2, it was negative and asymptotic with -2. What you would do over here is connect this together in a reasonable way. Yes, I'm using my graph. Yes, it's crossing the horizontal asymptote there. That doesn't bother me in the least. It's the vertical asymptotes that are incredibly dangerous. And what did you note about, with the sign analysis? And again, if you don't remember sign analysis, it should be in your notes somewhere. I have some recollection of it. I want to put out what I mean by that. We did this sign analysis over here. Hope you can recall that. What did I say between, the 0 and 4? It was negative and asymptotic with the 0. We did that by limit, by the way. Then what do you say? After 4, it became positive, but it became asymptotic with the horizontal line 1/2. So it goes up and it kind of goes towards that line up there. All right. Now, someone says, what are you doing over here? We're just talking through the past. That's all we're doing. Now, if you remember, below the -2, we said it was positive, but asymptotic with the line x equals -2 and the line y equals 1/2. How do you connect those together? In a reasonable way. And again, reasonable doesn't make it right. Again, a machine's doing this connection, but I'm just tracing over it. So then the question goes is, what's the range of this guy over here? Well, I got my picture down and I clearly see it. Now, what am I seeing over there? It's going down here, -infinity, goes up, covering all the numbers, and goes towards +infinity. Someone says, can I look at these guys over here? Of course you can. But this is the guy that's telling me what it is. What is it? It's all real numbers. Let me go over that, and I'll point out where that is. Sorry about that. Didn't mean to do that, but I'm going to go to that question over there, which is F. Whoops. And what's F? F is all real numbers. How would you write that down in interval notation? In interval notation, it'll be written as this way over here. Also can use the Blackboard R. All right, it's up to you. Let's go to the next question. And again, I know these are tough, and I don't mind you using technology, but the bottom line is you really want to start to think through what we're presenting to you and try to make sense out of it. All right, it's tough. Let's go to number 2. Number 2 says, oh, find a limit if it exists. And, my question over here is, I think I can do it without going to a table, but the bottom line might be tough. All right, so I'm going to go through it with you without doing the table, but I'll do the table later. And I'm going to talk about it. And the reason I'm going to talk about it is I'm really kind of, looking for sign analysis again. And I'm going to put this over here. And someone says, where are you interested in sign analysis? Well, they say at the number 1. All right. Now I want to do the right side. I'm going to write this over here. This is the right of it. and this would be the left of it. Now, someone says, what side are you interested in? I'm interested in the left. Let me point out why that is. If you look at this, this says we only want to go from the left. So I'm going to pick a number to the left of 1, but I want to be incredibly close to it. And I know that's difficult. I got to be honest with you, though. You could pick a number over here. I think you can. That's really simple. Someone says, what number would be simple over here to choose? And this could be somewhat dangerous. But here's the deal. What's a nice, easy number over here? I'd say 0. Plug it in. What do you get on top? Positive. What do you get on bottom? Negative. Overall, what would you get over here? You would get negative. So I know that the result of this thing over here, whatever it is, it's got to be minus. Now, I'm not sure what it is, but I know it's a negative number. Now, if someone said if you did the right side, let me just briefly go through that with you. If you took a number over here, I don't know, like 2, plugged it in, the top would be positive, the bottom would be positive. So over here, what do you get? All positive numbers, but they're not asking for that. All right, they're not asking. So my question over here, what would you get? What kind of number do you get? Well, I want to claim over here what you're doing here. You're getting really close to 1 from the left side. So if you get close to 1 from the left side, I hope you could agree that this number here, if you're close to 1, would become really close to 0. So if you're really close to 0, right, really close to 0, you can start to pretend it's 0. And what's on top? Some finite number. Right. Now, why do I know that? If you touch 1, what would you get? 1 plus 3 plus 5, which is 9. But you're dividing by an incredibly small number. What would that give you? An infinity. Let me write that down for you. By the way, thinking's difficult. It's something you want to start doing, particularly if you want to start to go toward calculus. But I'm going to say my thinking leaves me minus infinity. But what are they asking you to do? They're asking you to take values, and they tell you what values to choose. So what do they want you to do? They want you to use a computer at this point. And it can't hurt to do that. You'll learn by doing that. And what are you going to do in a computer? Well, you could do it in Sage if you want, but you'll say f of x is equal to x squared plus 3x. And then repeat this if you have trouble either using a calculator or computer. You really need to come by during office hours so we can discuss that on an individual basis. But what they want you to do, they want you to pick numbers to the left of 1, and they give you a table of values. And what I mean by this over here, they want you to evaluate f at 0.9. Now, before I do that, I want to claim that I would need a computer to do that. And the reason for that is I don't want to be here all day long doing arithmetic. However, it can be done. I'm not going to say all day long, but it'll take me a few minutes to get through it. I'm going to use a computer to do it, all right? Before I do that, though, I want to claim over here, where is the number 0.9? I hope you realize it's over here somewhere, but it is to the left of 1. I know that much. And if you use your computer to do that, I am going to claim that you should approximately get this number over here. Now, let's say you're using your computer and you can't get that number. That means you don't know how to use your computer. That means you need to come by during office hours so we can help you. All right. Now, someone says, what's the next number they're going to choose? Well, if you're at 0.9, they want to get closer. And what do? 0.99. All right. That's even closer to 1 from the left side. And if they use their computer to do that, they would get this number over here. Again, if you're using your computer and not getting that, there's something wrong with your use of a computer. When I say a computer, either your calculator or cell phone, whatever you're using to do computation. And if you did the next one, 0.99. Now, I got to be honest with you. If I were looking at this over here, and I look at the sequence 0.9, comma, 0.99, these are the x values, by the way, and 0.999. I'm going to claim, I hope you realize that this is getting close to 1 from the left side. And if I wrote the sequences of the y's down, or what the function is, this is the function f of x, and I wrote that sequence down, what sequence do I get? Minus 44.7895, comma, minus 449.754. The next number I got was minus 4499. And these are really crazy looking numbers. But I hope you start to realize, looking at those numbers, what am I looking at? I'm looking at this thing. I clearly see them all negative. And what am I seeing? About minus 45, about minus 450, about minus 4,500. Next one, I'd probably say minus 40,000, 45,000, further and so on. Where are they going? I would say, looking at that sequence, I would say it looks like you're going towards minus infinity. It looks like they're blowing up in a negative direction. All right. Now, what did we say? Yeah, it's blowing up in a negative direction. We said minus infinity. Tables are the most primitive way of doing things, but tables are going to allow you to think your way forward to limits, which is going to be the center of calculus, your ability to think limits. All right. And that's going to be tough. It takes time and effort. All right. What are we going to do now? Go to problem number 3. And number 3 says, find a limit if it exists. A little more difficult. And I want to tell you why it's more difficult. You could divide by the highest degree variable. Let me go through that with you. All right, I'm going to write this down for you. And again, it might say you do too much work. I don't like all the work you put down. And you need to learn to do that. All right, so I'm going to write this over here. Now, on top, my highest degree really is the root of an x squared. I want to point out, you should know that this is defined as either being x or the opposite of x, depending on what x is. Well, what's x? Well, if x was positive or 0, I'd get this. If x were negative, I'd get this over here, minus x. So let me write this over here, limit. I'm going to try to think through it. As x goes towards infinity, again, I want to point out what f of x is the square root of x squared plus 4 minus 2 over 2x minus 3. And this is tough. I'm not saying it's easier for students to do. But, which one am I looking at? And what I mean by this, which one am I looking at over here? I'm going to say I'm looking at this one. And why is that? We're going towards plus infinity. So it's got to be in this thing over here. So I'm going to circle this for you. We're going to divide the top by this. And we're going to divide the bottom by this. It's the same thing when you're going towards infinity. I'm going to write that down for you. Let's do the bottom first. What am I dividing the bottom by? This. Let's see if we can do it. And what would you get? 2 minus 3 over x. Now, what am I going to divide the top by? Well, it's either this or this. I'm going to do this and that. This one for this term, this one for that term. Let me write that down for you. And what would you get over there? I'm going to write this over here. You would get 1 plus 4 over x squared. Let me repeat what I did. I divide the top by this thing. This is the highest degree variable, by the way. Just this term over here. Now I'm going to divide this thing by that thing. What do I get? Minus 2 over x. And yeah, that's struggle. That's a struggle. Let's take a look. Where's x going towards infinity? What does that mean? It's a really large number. What do you get? Well, 3 divided by a large number is very close to 0. So the bottom is close to 2. Let me write that down for you. And what's the top going to be? Let's take a look at it. This would become 0 because 2 divided by a really large number is 0. What's 4 divided by a really large number squared? Still 0. So we're left off with the square root of 1, which certainly is pretty easy, 1/2. So I'm going to say I know the limit now. What's the limit? 1/2. All right. What did they tell you to do, though? They said, find a limit if it exists. I say it's 1/2, just by my reasoning skills. So it says also, maybe you should try to graph that guy. Yeah, who knows? Maybe that's going to help you. And again, graphing it, probably use of technology. What I'm going to claim, though, a lot of students need a primitive skill, which is a computational skill. So I'm going to point out what I would probably do just to learn the computational skill is I would go towards infinity. And what's a good sequence of numbers that goes towards infinity? I'm going to say, maybe 10,000. That's a number, right? 10,000 is a big number. What's the next number? Probably 100,000. What's the next number? Probably 1,000,000. I hope you realize I'm talking about the x's over here. And where are they going if I kept doing that? I hope you realize they're going towards infinity. That's exactly where we want to go. We want the x's to go towards infinity. Now the question becomes is, where's the function going, or the y? Let me write this down for you. This is going to be y. Where's the y going? Well, here's what you have to do. You would have to evaluate the function at 10,000. And I'm going to claim if you did that, you would get this number over here. Let me repeat this. If you can't do that on a computer, you need to come by during office hours so we can teach you how to use a computational device to do that, including using Sage to do it. It's really pretty easy to do. But again, you may not have that skill set. It's a skill set you want to acquire. So I'd write that number down, and let me write it down for you. What number would I get over there? Well, I'd get, 0. Whoops, sorry about that. I would get 0.499975. I even hate copying that number. If you did the next one, would you get, which is 100,000, you get another crazy looking number, which is going to be 0.4999. Let me count them up. 1, 2, 3, 4, 8. I hate writing those numbers down. If you did the next one, which is 1,000,000, what are you going to get? Well, most calculators at a level of precision are going to write down 0.5 and a bunch of zeros. Now, granted, I'm not saying it's equal to that. I'm saying it's approximately equal to that. That's all I'm saying. I'm not saying it's equal. I want to point out what that means. These are approximately. I'm not saying they're equal. They're not equal to that. Now, if you looked at that sequence of numbers and someone said, where do you think that sequence of numbers is going? I am hoping when you're looking at that, you were saying, I think they may be going towards a half. And that would be a reasonable guess. All right. That's what we're getting. All right. So we're going to say the limit is equal to this over here. That's number 3. Let's go to number 4. And number 4 is a problem. And someone says, what's the problem over here? It's this rational function. And we'll go through it one step at a time. All right. Want to claim what they're doing over here? They're giving you the function. They're giving you a picture. And they're asking a series of questions about it. Someone says, why do you do the picture for me? We are trying to teach. All right. What does that mean? We want to provide good visual aids for you to look at. At some point, though, you should be able to do this without a visual aid. Let me keep going. The first thing I would do is looking at the function. If I were given the function f of x, and that function was x squared minus 9x over x squared minus 9, the very first thing I would do is factor the problem. And what would you get? X, 3, 3. The bottom's really easy. What's top factor 2? X comes out, and you get x minus 9. Now, someone says, oh, you already did that for me. Why would I do that? You're trying to learn. But writing it down in factored form is going to be critical to you moving forward in these rational functions. We'll look at the picture later. I want to get to the questions. And what's question number 1? And I think I'm getting better at this. It says, what's the y-intercept? I don't know. How do I do that? Well, to get a y-intercept, it should be really easy to do. All you have to do is set x equal to 0. If you did that, what's f of 0? Well, I'm looking at the function. What do you get on top? 0. What do you get on bottom? Minus 9. What do you get? 0. So what is the y-intercept? It's a point where x is 0 and y is 0. They give me that. I want to go to the graph and point out, I see that. That's good news. Not only was I able to do that without a graph, but I could look at the graph and agree with the graph. All right, what's the next thing? What are the x-intercepts? Let's talk about that. All right, we'll look at the key later. How do you get an x-intercept? Again, we'll look at the picture later. All you have to do is set the function equal to 0. Well, let me write that down. What do you get? 0 equals, I'm going to write the function down in factored form, x minus 9, x plus 3, x minus 3. All right, that was pretty simple. What am I going to do now? Well, where does that become equal to 0? When x is 0, the solution to this is when x is 0 and when x is the number 9. So I now found 2 x-intercepts, 0, 0, and the other one's going to be 9, 0. Let's look at the key, see how we did. Oops, sorry about that. I'm seeing it. Let me look at my picture, though. Well, I already have the 0, 0 down. Let's see if I have the 9, 0 down. I'm seeing it. It's right there. I feel good about that. All right. Let's go to the next question, which I guess would be C, right? Moving this around. What's the domain of it? Well, that's pretty simple. It's all the real numbers. Let me write this over here. It's all the real numbers except where the bottom becomes 0. So X can't be plus or minus 3. We could write that in intervals. I'll write that down for you. Minus infinity up to minus 3, union minus 3 up to 3, union 3 to infinity. Let's look at the answer key. Whoops, sorry about that. Right over here. I want to look at the picture though. Whoops, I misplaced a thing over there. Let me look at the picture. I'm seeing it. I'm seeing this thing is everywhere except plus or minus 3. I'm seeing it. Okay, that's pretty good. Let's go to, oh, they want the horizontal asymptotes. Let's talk about that. How do I do that? And I got to make sure I can do this. I'll put this up here. So I'm going to do that horizontal asymptote business now. How do you do that? Well, limit as X goes towards the infinity and the limit as X goes towards minus infinity. Our recommendation is to divide the top and the bottom by the highest degree variable, which in this case is X squared. So what do you get? 1 minus 9 over X. If you're wondering what I'm doing, I'm dividing the top by X squared and I'm going to do the bottom by X squared. What do you get in the bottom? 1 minus 9 over X squared. Let's do the other one. It's pretty simple. I just did it. So really same thing. And we're going to do it now. And what does that mean? We're going to look at it and see if we can do it. As I do it, though, I want to point out X is getting really large. What do you get? 9 divided by a really large number, 0. So the top would be 1 and the bottom would be 1. And what's 1 divided by 1? 1. All right. Pretty simple. Really simple. So what does that say? It says the horizontal asymptote is y is equal to 1. Let's look at our key and see if we did that. Well, what am I noticing? I'm noticing I got both limits down and they got that down. I'm going to look at my picture now and see if they had that in the picture. And I'm seeing it. And I'll write this down for you. Horizontal asymptote is y equals 1. I clearly see that in the picture, and that's good news. All right, so I'm going to go to, I guess we just did D. I'm going to go to E. Now, when I do E, I still want to do the limits, but I realize I may not be at that stage yet. So what I want to do is I want to write the function down and I want to do sign analysis on it. And what's the function? F of X. And again, if you can't remember, hopefully it's written down somewhere. The top would be X minus 9, and the bottom would be X plus 3, X minus 3. And again, I'll do the limits separately. But before I do anything, I want to put a number line down. A number line, I want to do sign analysis. I'm looking for all the zeros in the problem, and they're kind of simple. I mean, 1 is at 0. That's where the top becomes 0. At 9, that's where the top becomes 0. And the bottom becomes 0. It means to split signs at plus or minus 3. So put this over here. I'm going to take some test points for you. Whoops, sorry about that. Press my button over there. Happens all the time. And I'll take test points for you. And so, what test points you're going to pick? I don't know, 10, 4, 1, minus 1, and minus 4. All right, let's do one. Let's do 10 first. Now, I want to plan what I'm doing. I'm plugging the 10 in. I want to see, is it positive or negative? Positive, 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 positive. Everything is positive. All right. Let's do the next one. Let's do 4. Positive, negative, positive, positive. It's negative. Let's do another one. Let's do 1. Positive, negative. Can't remember, just write it down. Positive, negative. What do we get? Negative over a negative, which is a positive. Whoa, let's do -1. Negative, negative, top is positive. Positive, negative, bottom is negative. What do you get? Negative. Now someone says, I can't do that. Well, you really got to go back to week number 1 and do sign analysis. It's important. I'm not saying you're fast at it, but you got to be able to do it and understand what we're doing. Let's do the -4. Negative, negative, top is positive. Negative, negative, bottom is positive. Overall, it's positive. So what am I going to do now? I don't know what you're going to do now. I'm going to do limits, and there's going to be a bunch of them to do. And this is where people get frustrated. They say, it's too much for me to do. Well, find something you like doing, and it's never going to be too much. All right. Hopefully it's a productive thing you like doing though. So I'm going to write this down for you. I'm going to write down limit. And someone says, where do you want to go? I want to emphasize where we want to go. Divisions by 0. So I'm going to say -3 would be one of them. From the left, f of x. Limit x goes to -3 from the right, f of x. Boy, I'll do another one. Limit, we'll look at our key later. This was nice out on keys. You make mistakes. You can say, oh, gee, I'll do it over. Yeah, you should if you make mistakes. And limit x goes to +3 from the right. Again, I want to point out the meanings of these things over here. This is the number -3. This is left side. This is the number -3, right side. This is number +3, left side, +3, right side. Let's talk about signs first. You want to approach -3 from the left side. That's got to be positive. And write that down for you. You want to approach -3 from the right side. This is the right side. What's the sign of it? Must be negative. I know this is tough though. You want to approach 3 from the left side. This is 3. This is the left side. What is it going to be? Positive. And yep, you're going to make mistakes. You want to approach 3 from the right side. This is 3. This is the right side. It's going to be negative. I hope you realize what you're really doing is when you plug in those numbers, you're dividing by a 0. What's going to happen? A blow up, which is an infinity. All right, let's go back and I want to see if I got it right. Just the limits. That's all I want to see. So one at a time. Did I get this one? This says, as you approach -3 from the left, it should be infinity. Bingo. This one says -3 from the right, it should be minus infinity. Bingo. We'll look at the picture later. This one says 3. I can't see that though. Oh yeah, from the left, I'm sorry. It's plus infinity. I got that one right. And this one says 3 from the right, minus infinity. I got that one right. All right, so what does this tell me? It tells me I have 2 vertical asymptotes. And let me write them down for you. We have 2 vertical, vertical asymptotes. VAs for vertical asymptote. X equals 3, X equals -3, right? I got those written over here. I want to go to the graph and point out, looking at the graph, I'm going to point out where I'm seeing those guys. All right, I'm going to write them down for you too. This is X equals 3. This is X equals -3. All right. Now, certainly someone says, you know, am I done? I don't know, maybe you are done, but it says over here, what's the range of it? And this is where we're graphing it. This is where it's so important to graph this out. And what I'm going to claim over here, I hope you realize we only have 2 points and a bunch of behavior problems. All right. But we also have sign analysis, and I'm hoping you can recall that. So what I'm going to claim over here, just look at the sign analysis of the problem. Between 0 and 3, we knew it was positive, but asymptotic with the 3. What's the connection between that? Probably something like this is reasonable. We knew through sign analysis between the number -3 and 0, it was negative, but it's asymptotic with -3. So something like this over here. All right. We knew from sign analysis that between the number 3 and 9, the function was negative, but asymptotic with the number x equals 3. We knew after 9, the function became positive, but it became asymptotic with the line y equals 1. Well, pretty reasonable. We knew from sign analysis that below -3, the function remained positive forever, but asymptotic. And just connect it up together. Now, what was the question over there? What's the range? Well, someone says you spent a lot of time graphing it, but you're only interested in the range. You need a graph to get the range, by the way. And why is that? I'm looking at it now. I want to point out this is the important feature over here. It's going down forever, coming up, and it's covering all the numbers. So what's the range? All real numbers. Let's go back to that. And I have to push things over a little bit. I know it's a lot of work. And it says, what's the range? We got that. The range is minus infinity to infinity. The way to write that down, you can write the Blackboard R. We do prefer to see intervals though. And we're done. All right. Let's go to the next thing up. And yeah, it's a lot of work. And we're going to do number 5 now. And number 5, I want to point out, there's an issue here that a lot of people are not appreciating, but I'll go through the questions separately. But my goal over here is if I'm seeing this, the first thing I would do, right, is I'd probably factor the problem. But I got to be honest with you, factoring this problem really doesn't help much, right? But let me write this down for you. To factor, what would you get? Well, it's a cubic on top, right? So you get x minus 2. We'll check it too. Don't worry about that. On bottom, doesn't factor. Not with real numbers anyway. What'd you get over here? X squared. Oh boy, how do you do that? If you remember, I go to the end over here. It's going to be plus 4, and this is going to be plus 2x here. Let's just see if that's true. I always say, I wonder if that's true. Multiply it out. What do you get? X cubed. I'm going to get my eraser after doing that, by the way. Plus 2x squared plus 4x minus 2x squared minus 4x minus 8. And what's nice about that? Well, a lot of things are disappearing. And that's good. I'm getting that x cubed minus 8 there. Let me get my eraser out though. And someone says, did that really help you in the problem? Not really. All right, not really. At least I know the factorization of it. The other thing I want to point out to you is that looking at it, someone says, I don't even remember you talking about this. Well, I hope you can remember a little bit. If I said the degree of the top is 1 more than the degree of the bottom, divide through, do a long division. I'm going to put that down for you. So I'm going to write this over on the side. Give me a second. I'm going to take x squared. Oops, go back to black ink. It's tough. Where'd you learn long division? Well, certainly when you're in grade school, but then certainly it's reinforced in algebra. A lot of students, what they have to do, then I'll point this out to them. Don't feel like you have to do it unless you have to do it, but they got to put the missing places in, and I'll do that for you. There's no squares. There's no linear terms, but there is minus 8. Do not feel obligated to do that if you don't need to do it. Erase this over here at the video. You can watch the videos too. So what times x squared would give x cubed? It would have to be x. And what do you have over there? X cubed plus 7x. Subtract. What do you get? Minus 7x. Drop a place down, minus 8. Wow, we're done. That was simple. So I'm going to write that down for you. And what would that give you? Well, this would give you something really simple. X plus something I didn't do, which divide minus 7x minus 8 by x squared plus 7. This looks strange to me. I'm going to write a little differently. So I'm going to write it as, I don't think I want to put the factored form down anymore, but x cubed minus 8 over x squared plus 7 is the same thing as x minus, this looks weird, I know that, 7x plus 8 over x squared plus 7. All right. Now, if someone says, do I need to go through all that work? Yes, you need to go through that work. Let's go to the questions though and see what the questions are. What's A? Oh, equation of slant asymptote. I'm glad I did that. So A, slant asymptote, what is it going to be? I'll point it out to you. It's going to be this thing. That's pretty simple. So it's going to be y equals x. How'd I get that? Through a long division, as we emphasized in lecture. Let me go to question number B. What's the y-intercept? I'll put that over here. Oh, before I do that, let's look at the answer key. Well, they did the long division and they got that over there. We're doing B now. And B is, what's the y-intercept? How do you do that? Set x equals 0. And that's really easy to do that. If you did that, that's going to be f of 0. Super simple to plug in. You get -8 on top. And what do you get on bottom 7? So I found it. What's it going to be? 0 minus 8/7. I'll put a box in that. Let me look at my key. I want to see if I got that answer right. And I did, right over here. All right, let's go to C. What, x-intercepts. All right, put this over here, C. X-intercepts. One point to get an x-intercept, all we're going to do is set the function equal to 0. If you don't remember what the function is, let's just write it down for you. It's x cubed minus 8 over x squared plus 7. It basically boils down to this. It's irrational. Is the top ever equal to 0? Yes, at 2. So this becomes 0 when x equals 2. Why is that? 2 cubed is 8, and 8 minus 8 is 0, provided the bottom is not simultaneously 0, which it is not. So I found my x-intercept. It's fairly simple. It's going to be 2 for the x, 0 for the y. All right. Let me go back and see if I got that right. Bingo, bingo, bingo. Oh boy. You know what? I'm going to look at the graph and see if my graph is giving me this stuff over here. And again, you may not remember. I just did the x-intercept. I said this, right? Push this over a little bit. And I said the y-intercept, if you remember that, was -8/7. So let me see if I got that. Oh, -8/7 is a little bit below -1. That looks good. That was the y-intercept. And they said the slant asymptote, I got that in there. What's a slant asymptote? It's right over here, right? Let me put this point down for you. This is 2, 0. And this point over here is 0 minus 8/7. By the way, I could not have read that from the graph. I'm not sure if that's -8/7. I am sure because I did the work though. And what's slant asymptote? It's y equals x. Okay, it's pretty simple, really simple stuff. All right. I'm not saying I get the picture, by the way. I'm answering the questions one at a time. And we're trying to build that skill set. Can you answer one thing at a time and connect the dots, so to speak? What's a domain? Well, you know what? You got to look at the original function. And I want to go back over and look at that again for you. And the original function is, where is it? Right over here. Well, what am I noticing is it's defined for all real numbers. And the reason being is the bottom is never 0. It's rational. So I'm going to say all real numbers. Let's take a look at it. Where did they say all real numbers? How would I write that down in interval notation? -infinity to infinity. Okay, if I look at the graph, and the graph is that black thing, I'm going to look at all real numbers. It does say that. Let's keep going to the questions. We did A, B, C, and D. Now we're going to go to E. Oh, what's the range? I got to do the graph. So someone says, how do you do a graph? I'm going to say by using sign analysis. All right. So I want to put that down for you. And what's nice about the sign analysis in the problem, I got some issues with it. All right. So someone says, what are your issues? I have to do sign analysis. So the question is, when would this change sign? At only one value, and that value would be at 2. So what do I do? To the right of 2, I pick a number like 3, plug it in, and what do I get? A positive number. If I went to the left of 2, like I chose 0, plug it in, you would get a negative number. So what I know about the graph, I know a lot of information now. I know to the right of 2 it's positive, to the left of 2 it's negative. Let's go back and draw that in. All right, let's talk about it. One thing I do know about the graph, it's asymptotic with the line. I know that much. I know below 2, it is negative, and it's got to go through those dots. So I'm going to say this is probably a reasonable connection for most people. Now, someone says, who did the graph? A machine did it. Now, after 2, I hope you realize it's positive, but there's got to be a connection. And I'll put this over here. I'm looking at my picture. I feel pretty good about it. And what's the range of this thing over here? Well, that's not an issue for me. I'm looking at a picture now. What's the range? -infinity to infinity. Let's go back over to the K. And I want to point out That's also listed for you. All right. Let's go to the next question. Make sure I'm doing this right. That's 5. We'll go to 6 next. 6 is, find the zeros of the rational function. Someone says, I don't even know what the word finding the zero means. All it means is this. When does the function equal 0? I don't know. Let's write it down. So what do you get? 1 plus 13 over x squared plus 1 equals 0. By the way, if you could do this quickly, do it quickly. We're not asking you to go slow. Like I look at this and say, oh, gee, that's really simple. But other people say, no, it's not simple. What are you going to do over here? I don't know. I guess I'd multiply both sides by x squared plus 1 if I didn't know what to do. I'll write that down for you. Why is that? It's the LCD in the problem. So what do you get over there? X squared plus 1 plus 13 is equal to 0. X squared plus 14 is equal to 0. X squared equals minus 14. X equals plus or minus from the square root rule, the square root of minus 14. And what do I know about that? That's a complex number. So it's plus or minus I root 14. And this is, I'm going to say there's no real solution to this problem. What does that mean? There are no zeros. All right. Now, when I said there's no zero, there's no real zeros. Let's look at the key. Now, what do they say? There's no real zeros. Okay. So I want to say that a partial graph is being provided to you. Someone says, why do you use the word partial? I can't give you the full picture, but a partial picture sometimes does give you the full picture. What do I notice about this curve over here? Well, it's always positive. I'm seeing that, always positive for my picture. And it appears to have, like looking at it, a y-intercept over here, but looking at it, no x-intercepts at all, right? But it appears to be asymptotic with the line y equals 1. Which seems to make sense, by the way, and I'll tell you why. If you look at this over here, it's 1 plus a fraction. And what happens when you go towards infinity on these guys over here? In either direction, this would disappear. All right, so that's done. That's a pretty simple question. And what I mean by simple, again, your mileage may vary on this, but it appears to be quite a simple question at this point. All right, let's go to the next one. And again, I want to point out what we just did. We just problem number 6. We're going to problem number 7 now. Give me 1 second. It's 7. Oh boy. 7 says use long division to rewrite. We'll look at the key later. I'll write this down for you. They said use long division to rewrite. X squared plus x minus 1 x cubed minus 2x squared plus 3x minus 5. I think I went too long with the long division symbol over here. Okay. What times x squared would give you x cubed? It would be x, right? And what's x times x squared is x cubed. Let's see, what would you get next? Plus x squared. That's not so bad. And then minus x. Subtract. You would get minus 3x squared. If you're struggling with long division, you'll have to go back and review Math 100. And there's nothing wrong with that, by the way. You want to go back and review. There's also tutors available at Essex College. They'll be more than happy to help you through the material. All right, what do you do over here? Minus 3. And what do you get? Minus 3x squared. Let's see, minus 3x plus 3. I'm going to subtract now. You get 7x minus 8. I'll write that down for you. So this will give you x minus 3. We'll look at the key later, plus unfinished business. I didn't divide 7x minus 8 by x squared. By the way, it can be continued. We don't do it at the Math 119 level, though. If you take calculus at Essex College, you'll be doing that in calculus, though, dividing through it. There's many ways to do it, all right? So I'm going to just see if I got the right answer. Who knows? Maybe I get the wrong answer sometimes. And x minus 3, yeah, I'm seeing it. Looks pretty good. All right, that was number 7. And then we're going to go to number 8 now. All right. And I'm looking at it. And when I'm looking at these things, I want to point out the way I do something, it may seem rather strange to you, but the bottom line is that at some point you got to stop watching people and say, what would I do instead? Right. Now, certainly you want to start to imitate, work of others, especially if you have teachers, you want to try to imitate that, but you need to develop your own style. But I'm going to go through the work. And someone says, why do you go through the work? I really want to go through the work. And there's many ways to do the problem. So let me write this over here. I write down, I'm given something. I see the graph of it. And I want to point out what I would do if I saw this problem over here. I'll look at the questions later. The first thing I would probably do is just simply factor it. That's easy. The next thing I would do, it's kind of dangerous when you did math like 092 and 100, they just did some really, I always say crazy things without thinking about it. They did something like this. It's a little bit dangerous, by the way. And what did they get? The x minus 3. This is only true if x is not minus 3. Because if it was minus 3, you'd be dividing by 0. That's one thing you could do. Now, what else could you do? If you looked at it and you really weren't thinking, you could also do a long division. Well, let me put the missing places in. For the students that need it, by the way. Not everyone needs it. Well, what times x squared? X squared would be x. That's x squared plus 3x. Then you get minus 3x minus 9. What times x is minus 3x is minus 3. What do you get? Minus 3x minus 9. Lo and behold, 0. Well, I get what I get over here. So I get a couple of forms of it. I'll write this down for you. So I'm going to say the function f of x is x squared minus 9 over x plus 3. It could be also written as x plus 3 times x minus 3 over x plus 3. And it could also be written as x minus 3. Again, provided, this is only true, provided x is not minus 3. All right. So let's take a look. Let's see what the questions are. I don't even know what the questions are going to be. So I guess I should go in order, right? So what's A? Oh, that's easy. A is easy. What's the y-intercept? Well, it could be easier. All you have to do is set x equal to 0. You can get a point. And what's that point going to be? Well, you're kind of looking at the function's really simple. It's, the top would be minus 9. And the bottom would be 3. And that gives you minus 3. All right. Now, if you look at the k, I see it. I'm going to look at the graph. And I want to point out this is the graph over here. And I see it. Okay. What's the next question? What are the x-intercepts? And I'm going to claim that's also really easy to do. And I'll put this down for you. This is B now. You set y equal to 0. Well, let me write that down. What would you get? And again, if you can't remember the function, it's written up there. I'll just blow it up a little bit. So 0 equals x squared minus 9 over x plus 3. Right now, if you just simply solve that, what would you get? I would multiply both sides by probably x plus 3. You would get x squared minus 9 equals 0. And then you realize you can just square rule. You get x squared equals 9. Right? 9. And x equal plus or minus 3. But there's a problem with that. So if you even go back to math 100, you have to understand that there's not two solutions. And why is that? You can't use minus 3 because you have division by 0. So there's only one. And what's that going to be? Well, it's going to be not at minus 3, but at 3, 0. All right. Let's look at the k. This is B. And they tell me that. All right. Let me look at the picture. And I want to see if I see it. I'll blow it up for you. I'm seeing it. All right. Let's keep reading it. All right. We just did A and B. Let's go to C now. C says, what's the domain of it? Well, that couldn't be easier. And why is that? I'll write it down for you. F of x is x squared minus 9 over x plus 3. The domain is all the real numbers. That's a 3, by the way. Except x can't be minus 3 because you have division by 0. Let me point out, it's written down for you. The next up, they say, what happens when you get close to minus 3? All right. And that's the limit problem. And that can be tough. Let's take a look at that. So I'm going to write this over here. f of x equals x squared minus 9 over x plus 3. I'm going to factor this guy. I'm going to do sign analysis. I hope you remember that. And that would be x plus 3, x minus 3. And then when you go over here, you get x plus 3. Let me do my sign analysis, okay? Show you what happens. It might seem strange to you. So I guess you get plus or minus 3, right? And I just take some lousy test points here. And, 4 is a good one here. 0 is a good test point over there, and minus 4 here. And let's plug it in. Let's do 0 first because it's easy. What do you get? Well, you get negative, don't you? Again, you may wonder where I'm plugging these things in. I'm plugging it in here. All right, I'm going to keep going. If you plugged in 0, you get negative on top, positive on bottom. Plugged in 4, what would you get? Positive, positive, positive. Everything's positive. Okay, let's go below minus 3 and do minus 4. What do you get on top? Negative times a negative is positive, and then you get a negative on the bottom, it's a negative. This tends to substitute. They always say, oh, it's got to be plus minus, plus minus. That's not true. You need to do this without bias. All right. So what am I going to do? I'm going to look at it. And this is the part where someone says, I don't know what you want me to do. We want you to look at limits. Right. This can get tough. And I want to tell you what they want me to do. They want me to get close to only one number, and that number is minus 3. From the left and from the right. Of who? F of x. All right, let's take a look. And my question is, what's the sign of it? And let me just point out what I'm talking about. Minus 3 from the left and from the right is always going to be negative. Now, this is where someone says, I'm just going to put the infinity in x. So I know you're dividing by 0. But I want to get this across to you. This is an important concept. This says get close to this number, but don't dare touch it. Let me repeat this. This says get close to this number, but don't dare touch it. So if that says that, what is it really saying? It's saying it's never minus 3. Let me go back up here. If this is never minus 3, what would this be equal to? X minus 3. Because this, remember, x is not minus 3 for this to be true. Because if x were minus 3, I'd divide by 0. So really, what am I left off with? I'm left off with a really simple function to evaluate. And I'm evaluating at minus 3. And what number would I get? Well, what's minus 3 minus 3? It's minus 6. Let's go back to see the answer. And that's what they're saying. Let's get back to red ink. Okay. Of course, we would like you to read, and it says there's a hole now. Let's discuss that. Let's go over here, and I want to point out the hole. They say the hole occurred at minus 3, minus 6. Now, why is there a hole there? The function's undefined there. So let me write that down for you. There's a hole, and this is a hole. The hole occurred at where x is minus 3, the y turned out to be minus 6. All right. Now, I hope you realize they probably want us to graph it. At least I think so. Let's see what there's a question. Yeah, the range of it. Here comes the part where she was saying, what are you going to graph out? Well, I'll be honest with you. Let's look back at the problem. And I'll go back over here. What's the easiest thing to graph out? And I want to point out, this is really easy to graph. But it's only true if x not minus 3. And what is this thing over here? It's a line. Let's go back over here and let's see if we got a line. Whoops. Yep. Let me draw the picture. No, you can't go through that hole. You can jump over it. I'm drawing the line x minus 3 now. Very simple line. Lines that you've done in Math 119. What was your question though? Well, you need a graph. The question is, what's the range? Let's write this down, the range. Well, I'm looking at it. It's definitely, minus infinity. And then boom, 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 boom. It doesn't do what though? It doesn't touch the number -6. I'll get rid of that then. Union, it starts up again. Let me put up, after I do that, and then it goes off this way. Let's write that down. And we'll look at the key later. All right, let's look at the key and see how we did. What does it say? Yeah, all real numbers except -6. Exactly what I have down. All right, so I think we did, again, I know it's a lot of work. I think we've done a lot though. And I don't know, what number is that? Oh, let's go to 9. 9, what do they say? Here's some really simple, manageable graphing problems. And I think I can do it quickly. All right. And again, you may not be at that stage yet because you haven't studied enough. But let's go to the next page and see if we can do number. Maybe it's on this page. No, it's on the next page, 9. And I'm going to do it real quick. All right. Manageable problems. Let's write this down, A. And when I mean manageable, this is manageable. I'm going to write domain down first. All real numbers. X cannot be +4. All right. I'm going to put down x-intercepts. And what's that going to be? 0, 0. That was easy. I'm going to put down a y-intercept. What's a y-intercept? 0, 0. That was easy. Let's see what else I could do. I guess I could do a horizontal asymptote, right? And what's that going to be? Limit as x goes towards infinity, and a limit as x goes -infinity. We'll look at the picture later. And that's going to be what's f of x? Well, it's 2x over x minus 4. I would divide by the highest degree variable. So that'll be 2, 1 minus 4 over x, 2, 1 minus 4 over x. And if you did that, you would get 2 in both cases. So what's a horizontal asymptote? Y equals 2. We'll look at the picture later, by the way. All right, what else could I do? I guess I could do the vertical asymptote, right? And the way I'd probably do that, I think I'd approach it using sign analysis. And so I'm going to say 0 and 4. I'll take some test points for you, like -1, 1, and 5. Let's do -1 first. You get negative on top, negative on bottom. We're going to be positive. This is important for me to do this. In time, you get better at it. Top is positive. When I do 1, top is positive. Bottom would be negative. So this is negative. And let's do 5. When you get positive, positive. So it's positive. So write the limits down. We'll look at the picture later. And what I'm going to write down is the only place that I'm really concerned about. And what am I really concerned about? I'm concerned about at 4. Let's write this down for you. The limit as x approaches 4 from the left, I'm going to remind you the function is going to be 2x, x minus 4. We'll do that in a moment. And I'm going to do the limit as x approaches 4 from the right, 2x, x minus 4. Now, certainly when I do this over here, someone says, why do you do this? Well, you're going to get better at it. I'm not going to claim otherwise. If you're to the left of 4, what would it be? Negative. Let's do the next one. And so what do you mean the next one? This next one, 4 from the right, has to be positive. Let's talk through it. I want to point out the top number is going to be some finite number. The bottom number is going to go towards 0. It's blowing up. Same thing over here. The top number will be finite. Any number after 4 is going to be a finite number. But here's the deal. You're plugging in something really close to 4 to get close to 0, and we know it's going to blow up. What does this tell me? I have a vertical asymptote, and that vertical asymptote is going to be x. I'm sorry, not x. I'm sorry, yeah, x. I'm sorry. I'm daydreaming. All right. So I think I'm ready. So what do you mean you're ready? I'm ready to graph it out. All right, let's talk about it. And we'll do one thing at a time. I want to do the x-intercept and the y-intercept at 0, 0. I got that covered. I want to put out what I mean by that. This is covered. I'm going to do horizontal. Last note, I said y is 2. I'm seeing it. I'm going to do the vertical aspect. They said x equals 4. I'm seeing it. All right. Now someone says, I don't see anything else in the problem. I want to talk about sign analysis. Before I do that, though, I want to talk about the limits. I'm going to talk about this one over here. If you're going to 4 from the left side, it's going to minus infinity. Let me talk about that. This is the number 4. This is the left side. This is the number 4, this left side. Where's it going? Minus infinity. Let me go back to that. Okay. Minus 4 from the right side, plus infinity. Let's go over this again. 4 from the right side, plus infinity. I'll put that down. Again, I'm just speaking through the limits. This over here, when you go towards infinity, it goes towards the number 2. When you go towards the minus infinity, it goes to the number 2. Well, let's do that. Whoops, I didn't mean to do that. Give me 1 second. When you go to plus infinity, it goes towards a line y equals 2. Push that over. When you go towards minus infinity, it also goes minus 2. Now, someone says, could you connect the dots together? Of course I could. Now, someone says, oh, the graph's already there. You know how to connect them. That seems reasonable to me, by the way. This seems reasonable. This seems reasonable. And we're done. Everything is done. Very manageable graph, by the way. Let's go to the next one. Should be B. And I'm seeing it. And I'm just going to go through it real quick, right? Like if I were asked to do that problem, I'd say, yeah, it's really simple. And let me go through it. So f of x, first thing I'd probably do is just factor it, x plus 2, x plus 5, x minus 5. And let me just go through some really quick things. Like the domain of it's really easy. It's all the real numbers except plus or minus 5. I can't divide by 0. All right, and what else can I do? Probably the y-intercept, pretty simple. What's the y-intercept? Set x to be 0. And what would you get over there? Well, it's minus 2 over 25. That's a nasty number, I know that. All right. It's not bad though. X-intercept. And we'll go to the picture later. Well, it's when the function takes on its 0, and that only happens at minus 2. All right. I want to go to the graph though, and I just want to look at this point and see how we did. I see it. Now, by the way, I realize this is tough, but I definitely see this minus 2, 0. This is a small number, but it is negative. And I'm seeing that right over there. I definitely see that. All right. Now, what else do I want to do? I want to do probably the horizontal asymptote. All right, let me put that down for you. So, the limit as x goes towards infinity. And I realize this looks tough to you. You may say, what's the highest degree variable? It's x squared. So I'm going to divide through by x squared. What would you get? 1 over x plus 2 over x squared. On the bottom, you get 1 minus 25 over x squared. We'll do that later. And towards minus infinity. I know it's work. What do you get on top? 0. What do you get on bottom? 1, 0. What do you get on top? 0. What do you get on bottom? 1, still 0. So I got a horizontal asymptote. I'll write that down for you. And what's that going to be? Y equals 0. Well, look at the picture and see if I got that. Well, you know what? I really don't see it drawn in there. I'm going to draw it in now. Okay, I got that done. What's that going to be? Horizontal asymptote. What is it? Y equals 0. All right, let's go to the next thing I would probably put down, vertical asymptotes. All right, make sure you do that. And yeah, I want to remind you the function. I'm seeing it. I'm going to do sign analysis. I think we've done this before, right? What are the zeros plus or minus 5? At the bottom, right? And the 0 on top is minus 2. Let's do some test points, really simple. Again, I'm hoping this is not causing too much anxiety for you. I can try 0 first. What do you get? Again, I want to put it where we're plugging in here because it's easy for me. Positive on top, negative on bottom. So what do I get? Negative. Let's do 6, positive on top, positive, positive. Everything's positive. Let's do minus 3, get negative on top, negative on bottom, positive. Again, simple sign analysis really learned in the first class, by the way. If you did minus 6, negative on top, negative times negative on bottom, positive, negative divided by positive is negative. Why do I do that? So I can do the limits. Let's write this down now. The limit as x goes towards, I want to point out what we're doing. It's the function x plus 2 over x squared minus 25. All right. And right over here, f of x equals x plus 2 over x squared minus 25. Again, if you can't remember something, you look back at it. All right, let's do this. And someone says, there's only 2 numbers that I'm interested in, and that's where division by 0 occurs. So at minus 5 from the left of f of x, the limit x minus 5 from the right f of x, the limit x goes to 5 from the left, the limit x goes to 5 from the right f of x. All right, let's go through sign. You'll get better over time. Don't worry about that. Let's do one at a time. So you can go minus 5 from the left. This is minus 5, this is left. What's the sign of it? Negative. Whoops, I didn't mean to do that. We'll look at the key later. All right, now I want to do minus 5 from the right. What's it going to be? Positive. All right, we're going to keep doing it. We want to go 5 to the left of it. Right over here, it's going to be negative. Okay, what do we want to do now? We want to do 5 from the right. What's 5 right? It's got to be positive. Okay, it's tough. I know that. Got to think. I do. Sign analysis. Now what are we doing? Well, if you plugged in the number either 5 or minus 5, I hope you realize this bottom is going to be 0, but the top is always going to be finite. So what do you get over here? But when I say finite, I mean, I should say non-zero. So I'm going to say that it's some finite number divided by 0. It's going to blow up every single time. All right. Let's look at our picture. And I really think I'm ready to go. I know it's tough though. I'm not saying it's easy. So I just want to look at this behavior problem. So I want to do 5 from the left. Oh, I'm sorry. I've got to write this down. There's going to be vertical asymptotes at x equals 5 and x equals minus 5. And I see those and I'll put them down for you. This is x equals 5. And this is x equals minus 5. Clearly see that. All right, let's take a look at it. And I'll talk about limits now. If you're going to 5 from the left side, it's minus infinity. Let me point out what I mean by that. It's this thing over here. All right, at 5 from the left, it goes to minus infinity. 5 from the right, plus infinity. Let's go over here. 5 from the right, plus infinity. All right, let's keep going. Okay, I'll point out what I do. Minus 5 from the left, minus infinity. Whoops. Push that over there. It gets a little dirty. I know that. So minus 5 Oh boy, I made a mistake again. -5 from the left, it goes to minus infinity. Let me write that down for you. -5 from the right, plus infinity. All right, let me blow this guy up. Let me just talk through it. Let me look at the middle part first. I know it's got to connect to that dot. I know it has to connect to that dot. And I know it has to connect up like this. Now, someone says, are you absolutely sure about that? Yes, I'm just not sure of the shape of it. I know there's a connection. Now let's talk about the other guys. To the right of 5, we did sign analysis. It's always positive to right. And it's asymptotic. What's a connection? To the left of -5, it always was negative and it was asymptotic with the 0. What's a connection? Maybe something like this over here. And we're done. What's the range of that guy? All real numbers. All right. That's B. Let's go to C. And I think it's going to be easy. I really do. I think it's so easy I'm going to be able to do it just by looking at it now. And the first thing I do about is I know the domain of it. It's all the real numbers except plus or minus 2. And why is that? Division by 0. What's the x-intercept? -8, 0. What's the y-intercept? And we'll look at the picture in a second. The y-intercept is going to be -2. Really simple. Let's look at our picture. Sorry about that. I pressed the button again. All right, let me look at this. I want to see if I got it, at least the points right. Oh, gee, I got this right. You see that? This is good. You know what? I'm not seeing the other point. I want to put on what I'm looking at. I don't see it. And why is that? They stopped at 6. And it's going to happen to you. You say, I wonder where that is. Well, what you got to do, let me scoot over. Give me a second. Let me see if I got another picture. Oh, yeah. I'm sorry. I also misspoke to you. And I apologize for that. Let me just make sure I got this. I'm trying to figure out what I just did. And you know what? I have to move things around a little more. I apologize. I'll put out what I was looking at. I was looking over here. It's not over here. It's over here. I'm sorry. It's right there. It is in the graph. I'll put that down for you. Seeing it. Oops. I'm screwing up. All right, I think I did all right with that. Got those two. All right. Let's look at the horizontal asymptote. All right. I'm going to put that down for you. The limit as x goes towards infinity of the function, highest degree variable is x squared. Kind of did this before, right? It's just going to be 1 over x plus 8 over x squared. And the bottom would be 1 minus 4 over x squared. Well, clearly the top would be 0 and the bottom's 1, so that's 0. And the next one's going to be limit x goes to minus infinity, 1 over x plus 8 over x squared, 1 minus 4 over x squared. Clearly the top is 0, the bottom is 1, so you get 0. So what's horizontal asymptote? It's y equals 0. Now, I really don't see that drawn there, so I'm going to put it in for you. All right, let's go to our next thing. I know it's tough. I'm going to look at sign analysis. All right, I'll put this over here for you. And put a little number line down. And I can say plus or minus 2. And minus 8. Well, you know what? I got to do that again. Minus 8 here, and then plus or minus 2. Let's do some test points. I don't know, 3, 0, minus 3, minus 10. Where are you plugging it in? Here. It should be really easy to do, by the way. Plug in 3, what do you get? Positive over positive, positive. If you plug in 0, what'd you get? 8 over a negative number, which is negative. If you plug in minus 3, what do you get? A positive over a positive, positive number. Again, if you can't do sign analysis, you really need to go back to the very first class and study that. You may not be fast at it, though. I'm not saying you are fast at it. You could be incredibly slow. Take your time. You want to get them right. Let's do minus 10. You get negative on top, positive on bottom, negative. Why do I do that? I can do the limits. And what am I interested in? Limits. The limit, as x goes towards those really dangerous numbers, which is going to be plus or minus 2. From the left, from the right. Scoot this over a little bit. The limit, x goes to 2 from the left. Limit, x goes to 2 from the right, f of x. I'm just initially going to talk about signs, and I want to emphasize what we're talking about over here. Minus 2 from the left is positive number. Minus 2 from the right is a negative number. Let's keep going. 2 from the left is a negative number. 2 from the right is a positive number. What are we getting? A division by 0. It's going to be blowing up. All right, I'm going to go to the picture. And as I do that, I want to emphasize what we're talking about over here. Minus 2 from the left says plus infinity. Minus 2 from the right says negative infinity. All right, let's keep going. 2 from the left says minus infinity. Again, I'm looking at my limits. 2 from the right says plus infinity. Okay? So someone says, how are you going to kick this together? Well, you could use sign analysis, but I do have points. I can say maybe something like this is reasonable to me. Maybe something like this. It seems reasonable to me. And what do I know after 2? I know it's asymptotic with y equals 0, and there's got to be a connection. All right, got to be a connection. And here comes the problem for a lot of students, and it's a problem. I'm not saying it's not a problem, but the problem is this over here. Right? You know, what happens over here? What happens over here? And this is why we blow things up for you. Now, I want to point out, if you blew it up and you thought about your sign analysis, we're still going to get this behavior we're seeing over here. But remember, when I was looking at the other graph, I really couldn't see what was happening over here. But now I can. I want to point out what's happening over here. The function is remaining negative. But I want to point out, eventually it's going to come back up and be asymptotic with that 0. All right. Now, this is where you get problems. And the problem is this. When you're looking at this thing over here, my claim over here is you cannot determine the range of this problem, other than the fact that there's most likely something missing over here. But I'll be honest with you, the reason you can't do that, you don't know the top point here, and you don't know the bottom point over here. But if you did know that, which you'd be able to do in calculus, you could remove that portion. But you don't know that yet. You don't know calculus yet. When you get there, you'll get there. All right. Let's talk about the next thing. And I think we're done with that. And we'll go to letter D now. And let's put that down. And this is D. All right, I can put domain down. all real numbers. X can't be 6, and X cannot be -5. I think I can put down X-intercept and a Y-intercept. Now, I'll put the Y-intercept down first because I think it's really easy to do so. And that would be 0. And what would you get? Well, if you plug in 0, you get -42. I'll write this down for you. Over -30. It's a nasty number. What's that going to be? 42 over 30. Still a nasty number. Let's divide. That's 21 over 15. I can divide by 3. That would be 7/5. All right. Let's do the x-intercepts. Well, what does top become 0? 6, 0. The other one will be -7, 0. I have to tell you, though, this is a common error people have. They don't really think it couldn't be 6. And I'll tell you why. Division by 0. I can't have 6 in the problem. So I got 2 lousy points. Let me go to my graph. And I want to see if I see those lousy points. So -7, 0. I'm seeing it. You get the idea? And what's the other point I'm supposed to be seeing? 7/5. Let me write this down over here. This is 0, 7/5. This point over here is -7, 0. Pretty simple. I got 2 lousy points. All right. So, what else you're going to do? I would say probably horizontal asymptote, maybe. It's tough. We're not going to, it's easy. But I'm getting better at it. I've been doing so many problems. I think I can actually do this. But I'm looking at it, and if you divide f of x in the top and bottom of the highest degree variable, what would you get? You get y equals 1. Horizontalize. Really simple. I don't see it drawn in. I'm going to put it in. And again, if students need extra help with that, you come by and stop. We'll talk about that in stages too. What else would I probably do? I'd probably do a vertical asymptote. Oops, I'm going to black ink. Well, I think it's really easy to do that. And I'll tell you why. I'm looking at the problem, and f of x is going to be a really simple problem. It turns out to be just simply x plus 7 over x plus 5 if x is not equal to 6. If it were 6, that couldn't be true. All right. So I'm going to claim over here, this is a really simple problem right now. It's going to be a graph of that guy over there, provided x is not equal to 6. So what I want to talk about is, what if x were 6? I'd get a hole. This is my whole problem. So what would this be if it were equal to 6? And I write this over here. What would you get? 7 plus 6, which is 13, over 11. Let me go to the graph. This is not an asymptote, by the way. There's going to be a hole. And the hole's right here. And what's that hole going to be? At 6, comma, 13/11. All right, you see the hole, right? So 6, 13/11. What's 13/11? It's a little above 1, right? That's not so bad. I got that hole covered. Let's talk about the vertical asymptote, though. How do I do that? Well, I guess sign analysis, right? And let's put that down for you. Kind of looking at it. I'm going to write the numbers down for you. -7, -5, right? And 6. Do our test points. 0, 7, I don't know, -6, -10. So where are you going to plug it in? You could plug it in here. You could plug it in here. Or you could plug it in here. Let's go to town. Let's try 7. What do you get? I'm going to do it here. You get positive or positive, positive. If you tried 0, what would you get? Positive or positive, positive. If you tried -6, what would you get? Positive on top, negative on bottom, you get negative. If you tried -10, what would you get? Negative on top, negative on bottom, which is positive. All right. I'm going to do my limit now. Limit as x goes towards the number that's dangerous, which is -5 of f of x from both the left and the right. Let's do one at a time. -5 from the left, it's going to be negative. Let's do the next one. -5 from the right, it's going to be positive. This is a blow-up problem. These are infinities. Okay, let's look at our picture and let's see if we see an asymptote, which I'm expecting. What am I expecting to see? An asymptote x equals -5. Let me go over here. I'm going to point this out to you. And I'm seeing it. And what's that going to be? X equals -5. Let me just go back over this with you. As we approach -5 from the left, it's minus infinity. And as you approach -5 from the right, it's plus infinity. Can you connect this all together? Of course you can. And what would you see? You see something like this over here. Now this one over here, you see this connection over here, and this is asymptotic. All right, something like that over there. Someone says, the range, it's more difficult. I know that these pictures can be highly deceptive, particularly if you don't know calculus, but kind of looking at it, I'm kind of looking at it. The range of this guy over here, just look at my picture. It's tough. I'll write this down for you. Certainly I'm seeing it go towards minus infinity. And it goes up to what? Looks like it's going up to 1, but not touching it. Union, starting up at 1. Oh, and then what does it do? It looks like it goes toward 13/11ths, but not touching it. Union, I'm sorry, I backwards on that. I said 13/11ths, right? Union 13/11ths to infinity. This is tough, though. I realize that. That's about it, though. I realize this was long, might have been tedious for you. You might have to come back and watch those little spot videos on your own. Okay. Thank you so much.